Hello everyone. For this tutorial video, I'd like to explain how to compute improper integrals, which are integrals that have breaks in their points or discontinuities, instead of the more well-behaved integrals we have been studying up to now. An improper integral is given its name because either one of the terms in the integral returns infinity or negative infinity, or one of the limits of the integral is infinity or negative infinity. Although this would normally be a problem, we know using limits we can approximate functions approaching infinity, so we would use the limit of the integral rather than an exact integral. For example, the integral of 1 over x squared relative to change in x from 1 to infinity cannot be calculated directly. Well, if we take the indefinite integral, set it to an arbitrary point t, and then 1, we would get 1 minus 1 over t for our integral. So now we take the limit as t approaches infinity, as that was what we were given in the prompt. And as t approaches infinity, 1 over t approaches 0, so we have 1 as our final answer for the integral, which we can confirm with a graph of the integral if we remember one interpretation of it is the area under a curve. It may be a little surprising that the area is finite despite one of its components being infinite, but if we remember we are taking a limit and not a literal value, this may help it make sense somewhat. If we were asked to integrate 1 over x rather than 1 over x squared, the answer would change, because the integral of 1 over x is ln of absolute value of x. So we have ln of t minus ln of 1 as t approaches infinity, and ln of infinity is infinity, and infinity minus anything, as long as it's finite, is still infinity. So in conclusion, this area is infinite, which again makes sense if we look at a graph of the integral. If we instead have 0 as the upper limit and negative infinity as the lower limit, we would calculate the indefinite integral as usual. But this time, notice that t is the lower limit rather than the upper limit, and as t approaches negative infinity, the portion with t in it approaches positive infinity because we are subtracting a value that approaches negative infinity rather than adding it. So the finite part plus infinity is still infinity. That is our final answer for the integral. Now that we have figured out different types of improper integrals, we are ready to move on to the final topic, which is approximating integrals you cannot compute directly, as many integrals will defy all the techniques we learned in Calculus 1 and 2. Don't forget to subscribe if you found this video informative, and make sure to see the other tutorial videos, and follow me on either Facebook or Twitter for more content.